The LeetCode problem we are going to solve now is called edit distance. We can see that this one is a LeetCode medium problem and also extremely well-liked problem on LeetCode. Basically, we are given two strings, word1 and word2, and we need to return the minimum number of operations that we need to do in order to convert word1 into word2 completely. Now we have three operations that we are allowed to do. We can insert a character, delete a character, or replace a character at any single moment, and we can come up with the solution. So let's try to understand some of the examples on how long will it take. So let's say that if the given word 1 is horse and word 2 is Ross, in this case we'll need to do three operations basically to convert this word 1 into word 2. First, we will convert this H into R. So now we are left with two words, basically RORSE and then ROS. Then we will keep O as it is and R as it is. Now we can delete this R. So notice that now we have the two words as ROSE and ROS, and then lastly we can also delete this E. So basically we have both the words same. So notice we did three operations. First one was the replace operation between these two values. Then we simply go ahead and deleted this R and then deleted this E, and that's all the problem. Same way, if we are given three words like A, B, C and XYZ, in this case the only thing we can do is we can replace each of the character one by one. So in this case we also need to complete or take three operations to come up with this solution. Let's say if we are given two words that are exactly same, so in this case we don't need to do any operation and we can simply return 0 as the answer. So basically the idea is that we have the ability to either insert, delete or replace a character, but we'll have to convert word 1 to word 2 basically. So now let's try to understand that what would be the brute force approach to solve this problem. So in this case, as a brute force, at every single character we have the three probabilities that we can choose for, and we can replace the character with whatever character we have over here. We can delete this character, and we can create an or we can insert a new character. So we can take each of this subsequent path, and then over there we will also have three more possibilities, and we would continue to keep on going down each of the path until we find word 2, and we will find all the possibilities of generating word 2, and whichever has the smallest distance we will pick that. Now notice that this is a very expensive brute force solution. Why? Because at every single node we have possibilities to go down to three other nodes, and even for those three nodes we have subsequent more possibilities. So basically we are running into issues of exponential time complexity, and that would directly be dependent on the total number of words present for word and word 2, which is very expensive. So we'll have to find a smarter and clever way to come up with the solution. Now logically the only thing that makes sense in this case would be that because we are dealing with word 1 and word 2, and we are dealing with all the values that we currently have. Now notice that whatever the result that we have computed so far would impact on the subsequent result we are trying to generate. I'll repeat what I just said. Basically, currently if we have to generate like A, B and A, X and Z from this given A, B, then what possibilities we have? Like we know that first character is A, so we can keep it as it is. Now we are dealing with generating this B with this remaining X and Z. And for that what we can do, so with the B we will have basically a character, so we can just replace it with X, and then we can insert Z over here, so we can generate an answer like this. But the thing is, notice that we don't know subsequently in word if this value was to A B Y Z. If it was something like this, then we would have our choices differ. If we had some other values where we are trying to come up with a solution where let's say that this is A B Z, and the next value we are trying to build is A X B Y Z. So even in this case, every single moment we are trying to make the decision, we will have to compute that what was done for the previous values and take that into consideration. And I am giving all of this explanation just to explain that we will be using the most beautiful approach to solve this problem, that is using dynamic programming, where we will compute every single possibilities. So we'll compute that if we have to generate this word and the only word given is currently a, what would be the answer? AB, then what would be the answer? ABZ, then what would be the answer? And so on and so forth. If we try out every single permutation combination and have a 2D matrix to keep track of all of these values, then we'll be able to solve this problem very efficiently. Now, what are the possibilities we have at any given location? Remember, we can do three operations. We can do an insert operation, we can do a delete operation, we can do a replace operation. And for each of the three operation, if we only do this operation if the current characters that we are dealing with for the word 1 and word 2 do not match. So let's say if they do not match, we need to do these three operations, but we are only going to be selective, and we will look at the previously computed results from our dynamic programming array. And for that, we would be able to determine that if we do insert, if we do delete, or if we do replace, what is going to be the cheapest operation. And we will do +1 because we are adding one more operation, and then compute the result. Now let's try to understand this with an example, and it would make much more sense on what I'm talking about. We are going to take into the consideration for the same input that we were originally dealing with, where word 1 is horse and word 2 is Ross. Now notice that I have created one additional row and additional column on the each side, and that is to take care of the scenario of what if word 1 is completely empty and what if word 2 is completely empty. And based on that, we will build our solution, because remember, for dynamic programming we need two things. We need a base case and we need a recurrence relation. So base case is what if the word is completely empty, then we know that we will have to only insert the character and build the solution. And recurrence relation is the three subsequent neighboring cells that we have already computed for any particular cell that we are trying to compute. So let's see a scenario like this, where presumably word 1 currently is null, and we know that, let's say that given word 1 is null, and for the word 2 that value we are given is also null, then we basically do 0 operations, because we can't do anything to, because they both are exactly same. Now if word 1 is still null, that is what this row defines, but word 2 contains the value only r. Now if word 1 is null and word 2 is r, if we want to generate r from word 1, what will we do? Basically we would insert a character, so we would do one operation, insert operation, where we are inserting a value, and that is what we are doing over here. So in order to generate only r subsequent with the given current empty word 1, we would need to do it with one operation. Same way, if we have to generate ro and this word 1 is null, we basically insert two characters, so we are going to do two operations. Now notice in this case, we don't need it to compute for this full value, because we already know that in order to generate r, we only needed to do one operation. If we have to generate o, we know for a fact that for to generate r, there is only one operation needed. So for ro, we only need to consider the maximum number of operations needed to generate r +1, because we are inserting a new character, and that is supposed to be 2. Same way for ROS, we are not going to compute the full thing, but we know for in order to generate RO, it takes 2 operations, and then if we have to add S to it, it adds one more operation, so this is going to be 3. Same way, let's imagine that for this particular first column, if the given word 2 is, let's say, null, and the given word 1 is, let's say, all of this HORSE, horse, then what we would do in order to generate this value? Well, if it's going to be null, we can add it as 0 because both values are same. But if this word, same way, if this word 2 is equal to, let's say, null, and word 1 is currently H, then basically we will have to delete H, because we are trying to build word 2 from word 1. So in that case, we will have to do one operation. Same way, if we have to basically given word 1 as HO and word 2 as null, once again we will have to delete H and delete O. But we don't need to calculate how much time it takes in order to do both of this. We already know that it takes one operation to delete H. Same way, it's going to take 1 + 1 operation to delete HO. So this is going to be 2. Same way, this is going to be 3, 4 and 5 subsequently. Now notice that at every single character that we are trying to build, we basically have three possibilities. Let's say that currently word 1 we have is, so for this case this is going to contain value h, and word 2 we have is only going to contain value r. Now in this case, for both basically h and r, if we want to generate this, what are the options we have? For word 1 we can either replace, delete, or insert a character. And if we were to replace a character, basically we simply take whatever the previous value we had over here and we just replace it. We do the replace operation. That is option number 1. Second option is, if we have to delete the current character, if we have to basically, if we are trying to delete this h, then this is the scenario where h does not exist, only r exists. So we take whatever the value we have over here and do +1 over here because we did a delete operation. So that would be the subsequent value over here. Or if we have to insert a character, basically in that case r does not exist. So in this case, once again we take whatever the value we had over here and do +1. So now notice that in order to build this cell, we have three corresponding relations with each of these three subsequent cells. We can do whatever operation we want to, but basically in each of the cases, our number of operations we are doing relies on the subsequent neighboring cells. So if we do +1 amongst these three, then basically we can generate that value. But the thing is that +1, we are going to pick the minimum cost it takes to build this cell amongst these three. So for these three values, we will do +1 and we will see that what is going to be the minimum value, and whichever the minimum value is, we are going to insert that value over here. So I hope that logic is understood to you why we are picking this value. But basically in this case, notice that if we do +1 over here, the value becomes 2. This also value becomes 2. But in this case, this would turn value to be 1. So we are going to keep value as 1. Now notice same with this character is h, this character is o. Once again, they do not match. And because they do not match, we have the option to do all of these three operations. They depend on the neighboring cells. The neighboring cells we already know. So once again, we will do the minimum amongst these three. So the total is going to be 2, and basically +1 with the minimum. Same way for this one, the minimum +1. So the total is going to be 3. So what does this 3 defines? This defines that if we have given word 1 as h and word 2 as basically ROS, in order to do that, if we have to do that, it takes 3 operations to build that this word ROS from this word 1h. Same way we are going to be doing for every single possibility and combination. Once again, now notice O and R do not match. So we will do the minimum operation. So minimum is going to be 2. Once again, now in this case, because this O and because this O match for this particular cell, if there is a match, we don't need to do anything, and we can just take previous subsequent diagonal value we had, where basically we are not doing anything, we are just keeping the value as it is. So this is going to be 1. Same way, if we have to do this now, because the values do not match, so it's going to be 1 plus 1, so this is going to be 2. Same way for this R and R, because these values match, we will take the diagonal value 2. Once again over here, the sum is going to be 2, and once again for here, the sum is going to be 2, and that is this diagonal sum. Okay, same way for this S and R, the values do not match, so this will become 3. S and O, once again values do not match, so this would become 3. Now S and S do match, so because they match, we will take the diagonal value and keep 2 as it is. Now same way for this particular cell, the value is going to be 4. For this particular cell, the value is going to be once again 4, and for this particular cell, the value is going to be 3. And whatever the last value we have on this 2D array, that would basically define that if the word 1 was the full value, so HORSE, and if the word 2 was the full value ROS, then it would take 3 operations to build word 2 from word 1. And we can return 3 as the answer. So this is going to be the whole solution. Now if we see time and space complexity, in this case the time complexity is going to be big O of m multiplied by n, because we'll have to iterate over every single value that is currently present. And in terms of space complexity, well, because we are using an additional 2D array, this is also going to be big O of n multiplied by n. But overall, this is much better than our brute force approach, and this is a beautiful example on how dynamic programming can be powerful for us to solve any problem, especially like the recurrence relation problems. Okay, so let's try to see the coding solution for this now. So the coding solution is quite straightforward. Basically, we are going to define two variables m and n to capture the length of word 1 and word 2. Then we are going to initialize our 2D dynamic programming array that is going to be of size m plus 1 and m plus 1, where we will need to create a scenario where m and n are defined as 0, and then we will find values for those as well. Then we will initialize our value for basically each of the words. So like for word 1 and word 2, if they were given alone, and then we will try to fill in the values for both word 1 and word 2 in subsequent first row and first column. After doing that, we will fill in the rest of the dynamic programming array, where we are iterating over every single cell that are not filled, where we are checking that if the given subsequent word 1 and word 2 are same, then we will just choose whatever the previous value was from the diagonal value. If that is not the case, we will check all the three adjacent neighboring cells plus 1 and try to find the minimum value for each one of them. So basically we will try to replicate the scenario on if we have to delete a character, replace a character, or insert a character, and whatever is going to be the least cost, we would put that in the current I and jth value. In the end, we simply return the result or the very last element inside our dynamic programming array, and that should provide us the distance it takes to generate word 1 from word 2 or vice versa. So let's try to run this code. Okay, seems like our solution is working beautifully. Let's submit this. And our code works well and beats most of the other solutions in terms of time complexity, so which is pretty good. And once again, the coding solution would be present on our GitHub repository, so feel free to go and check it out from there. Thank you.